Cool, apparently it's recording. Alright, I think we'll start. So the first thing you want to do is open up your Visual Studio. I think most of you installed the C# 2010 Express. So you want to go to New Project. And what we want is a WP, Windows Presentation Foundations application. So that's the second one on the list, I think. Double click on that. Wait a while if you've got a slow computer.
Loading now, as opposed to what it was doing before.
It's an old computer. I'm surprised it actually runs.
That's cool.
Right. So the first thing we want to do is set up the size of the screen. So go to Properties. Set the width to whatever. We'll make it 640 by 480. And we'll want to add a canvas because we're going to have, ideally what we're going to have in the product is going to have an image with 3 circles. The 3 circles are to show where you're tracking, and the image is your video source. So we drag a canvas in. You'll need to get to the toolbox. You can get that by, I think, Control-Alt-X or through Weird. Go down to canvas, drag it in. Probably want to set the canvas size to the same size as before, which was 640 by 480. And we'll want to add the parts that we want.
You have to pull the canvas over the top of the background or whatever it is.
Yep, just drag it in. And then we'll add an image. Now you can have the image as big as you like. For completeness, we might as well make it the same size as the canvas again. So it's not really all that important, it's just for visual purposes. And finally we want to add 3 circles in. And these are just going to be where you track, later on we're going to have it track your body so we can see what's being tracked. They're called ellipses actually, but I'm going to call them circles, so I'm going to make them circles. We'll make them 40 by 40. And we've got to give them a name. Let's give it, that can be the head. Let's copy and paste it. And change that to be left circle, the left hand, and make another one, and make it the right hand, well, right circle, sorry. So head circle, left circle, right circle. Now, so that's got our UI sort of set up. It doesn't really matter where the circles are because we're going to move them, well, it's going to move automatically once it detects the skeleton. Also setting up your environment, you'll want to add the references because this is, and you'll need to do this for every project that you do. This is just so you know where the Visual Studio knows where your libraries are. So there's 2 main things that we want to add, 3 actually. The first one is you go to .NET and then you go to Microsoft.research.Kinect and that's your main Kinect API. And the other reference you want to add is the coding for fun thing that you should have. So you'll have to go to browse and look for wherever that is, wherever you downloaded it to. And I forget where I put it. Let's try that. And in this one, there's two deals you can get. The one I use is just the normal WPF one, and that's just because we're using when we started our project, we used the WPF application. And finally, because we're going to try and control the PowerPoint things, we'll need to be able. The way we're going to do that is we're just going to tap into the system and sort of send the left and right arrow keys. And to do that, we'll need to get Windows.forms. System.windows.forms, I think. That one there. There's two main events that we'll want to do, and that's basically when we start the application, we'll want to start the Kinect, and when we close the application, we'll want to uninitialize and tell it we're not using the Kinect resources anymore. So to do that, we need to go to events on the side here. We'll look for loaded, double click on that, which will create something. Go back to the XAML and find closed. So that should just put the code in your thing. And now we can start actually writing stuff. How's everyone following along so far?
Sorry, I just missed what you said on events. So you
Right.
go to events.
So you go to events, you search for closed and loaded, and you just double click and it should put code in your thing.
Yeah.
So closed and loaded. And that should get you here. How's everyone else going? Following along? No comment? Okay. The first thing we want to do is, the next thing we want to do is initialize the runtime environment. So you go runtime, and now you can call it whatever you like. This is outside the scope of the classes, so this is sort of like a global variable. We'll call it NUI for Natural User Interface. Actually, before we do that, we need to tell the system we're using them. So using Kinect dot Microsoft dot Kinect dot runtime dot Microsoft Research dot Connect. And we want to use the coding for fun. .connect.opf. Actually, we don't want just Connect. We want to get straight to the, because we're not going to use audio at all today, we just want to get the natural user interface, so NUI. And then we'll initialize that, and we'll call it NUI as well, just because. And so runtime NUI equals new runtime this is new runtime, that's why. So that's just creating the NUI, but we need to actually initialize it. So inside, when we want to initialize it when the window loads. So in here we go NUI.initialize, and there's a few runtime options that we can have. And this is what you'll have to do every time you set up your environment. You got to pick which parts of the Kinect you actually want. There's use color, that's just your normal RGB camera. You can get your depth camera and then use skeletal tracking. Because we kind of want to see our picture, we'll use color. And we'll also want to track skeletons, so we'll add the other one as well. Now that we've initialized it, we also want to uninitialize it, and this part's important because otherwise your Kinect's just always going to run. So you go nui dot uninitialize in the window closed. How's everyone going? Following along?
Yeah.
Cool. So after we initialize the runtime, the first thing we're going to split this up into 3 sections. The first thing we're going to do, we're going to get the camera working, so having the image pop up on the screen. Then we're going to get the skeletons to actually track you, and so you can get the information about, you get the clips, the circles you made to follow your skeleton. And then after that, we're going to actually make it control the presentation slide thing. So let's get the camera going. So you go nui dot video frame ready. So this creates, this tells you when, this fires off an event whenever the Kinect sees movement or when it gets a camera event. And you go plus equals, and then you just press tab and it'll automatically create it for you. So if you press tab twice, and you also want to create, or you want to open the video stream. So you go to video stream and then you go open. Now there's a few different settings you want to set here, but most of them will autocomplete for you. So the image stream type is video, because we want video. The pool size, I can't remember why you picked pool size, but usually everyone just picks 2 for that. And then the image resolution, because we started off, we'll just go for 640 by 480. And the default Kinect RGB camera is 640 by 480 anyway, so that works out great for us. And we want color. Now, whenever the video frame event fires off, we don't want to throw an exception. We want to actually do something. And this is where we actually use the coding for fun library, because what you could do, so we're going to say, is take the image that we made earlier, and we set its source to be the camera stream. Now, we could do it a full way. What you normally have to do is set a whole bunch of variables, but the better way of doing it is using the coding for fun. You go e.imageframe.to bitmap source, and that has all the parameters done for you. So now, if you run it, I believe, so Control-Shift-B to build it. You don't really need to do that, but but you just press F5, it should run. And it's got an error. That's so helpful. It's not helpful at all. Oh no, there we go. Now I haven't actually set up the video, I didn't set up my canvas UI properly by dragging it around, but everything is there. I'll just try and fix that up. Where's the image? Much better. So the people who have their Kinects plugged in should be able to see themselves, or should be able to have the camera come up. How's everyone going? Are you just waving or do you have
I'm
questions?
waving at the camera.
Good.
Go ahead.
Keep going. Or wait a minute.
So there's like only one circle of the screens then?
There's 3 circles.
Yeah.
They're just black, so you can't really see them. We can add a fill, make them colourful, bright. So select that, and select the circle and go to fill, and make it red, I guess. Any colour's fine, but red stands out. So you can see the circles now. Okay, so I think the problem I did earlier was the first thing I set to where I changed the size on the width and the height of the original window, where it was automatic. Before it was automatic, and I changed it to be fixed, and that's why some of you, when you start off, things are off center and going off places. So that was a mistake, but it's easy to fix. You just drag things around. Is that working? Cool. We'll move on.
I don't know where it is. I can tell you what it is.
So some of you seem to get it to be working. I might move on to getting the skeleton tracking to work. And if we, after I finish, we can go through and make sure everyone got it working, got everything working. So.
It's also known as here, but it's in the middle. It's somewhere else again, but it's also known as to replace it. So it's plus.
So the next thing we're going to try and do is get the skeletons to work, so getting it to actually track you. So once again, we just have to fire off a skeleton tracking event, and that's you go nui.skeleton frame ready, and once again plus equals, and then tab, and it should make it for you. We don't want exceptions when it happens, but what we do want to do is we want to find the skeletons. That the first thing is what happens is it'll give you a frame with up to 2 skeletons. So it'll either detect a skeleton, not detect, or detect 1 skeleton, or detect 2. For our purposes, we're just going to get it to look through the first skeleton and track that one. So the way we do that is to, hold make sure I get this right. Your skeleton frame. So this gets all the skeleton's data. But we only actually want to look at the first skeleton. So we look through the set of skeletons, and we only we only want the ones that are actually being tracked. So actually I was wrong. The Kinect actually detects 6 skeletons, but it only tracks 2 of them at a time. So it'll know, it can see that there's 6 people in the background, up to 6 people in the background, but it'll only be following 2 people. So out of the skeletons, we want to look through the ones that are tracked. It's not how you spell tracked. And we want to get the first one. Now we want to make sure that the skeleton actually exists. We don't want to start doing operations on null data. So if skeleton does not equal null, then we want to move the circles. So we haven't actually created anything, a method for moving the circles, so we'll make that now. Void, we'll say set circle position. Strictly speaking, they're ellipses, but we made them circles, so I'm going to keep going through as circles. Now, the way that the Kinect tracks the skeletons is it has a set of, I think, 42 joints that it follows, and you can access them using the joint, and they all have a joint ID. So we'll come back to that in a second. So every time that we find a skeleton, every time the skeleton moves, we track it, and we want to fire off. We want to do something with the joints. So we call this. What we want to do is we want to move the circles. So we go set circle position, and we're looking at the head circle.
Is that the name of your circle?
Yes. So the first one is the name of your circle that you want to move. Probably be ellipse 1 if you didn't change it at all. Right. So on yours we'll make ellipse 1 your head. Now we look through the skeleton, we get its joints, but we want to look by its joint ID. So joints is actually an array of joints, but each joint has a position and a whole bunch, and position, sort of depth of information, and quite a few things. We might come back to that. And we just want to get past the right joint. So we want the head, so we go joint ID dot head. This is the first one. We want to call it again. We want to move the left hand, I guess, left circle. Same thing again with So now every time something moves and it's detected as a skeleton, it will call this method, which currently does nothing. What we want to do is we want to make it get the position of where you saw your hand and move your circle to match that. So the way we do that is you go, because we originally added everything into a canvas. Yep.
Just quickly, I don't think you had yours inside the canvas on your model. Just want to quickly check that. You've got a canvas, but you have to come inside the canvas.
You're correct. Thank you. So let's put them all inside the canvas. Probably don't need a grid. See if that works. This might. So we want to set the left and right position of each of the circles. So canvas.setLeft. The element is the circle, and the position is going to be, you go to joint dot position. But we want the left, so that's your x value. So each position, the Kinect gives you, for each joint, it gives you an x, y, and a z. So x and y is your, I suppose, 2D image, and then z is the depth. Now depth can go between, I think it's 0.8 of a meter up to 4 meters back, but you usually don't want to work with all that, so we can set those values. And it's stored, x and y are stored in numbers from -1 to 1, I think. But we just want to set the joint position to .x. And set right, oops, set top to circle. So if you run that, and I have to realign everything because I changed the canvas. Move that. So now if you go, should hopefully track the, no. Okay.
So what is your legs?
Can't see my legs.
Just put it edge of that. Mine just tracked being all three moved up to 0, 0.
Okay. So something's missing. It might be. All right, I know what's missing. So as I said, everything's based off a number 0.1 to not to. So 0, 0, 0. So just times everything by the size of your screen. And I think that should work.
scale is down.
Okay, so as you can see that the scale is wrong, and that's by on purpose actually. So what we it actually is. So what we want to do to fix that is we want to scale everything to base to match your thing. So instead of doing the way we did, instead of doing times 6 by 40, you can either do maths here, or you can use the coding for fun and use another library thing there. And the one we're going to use is the scale joint. So we're going to scale it by going joint dot scale. .640 by 480. So now it's going to scale all your values to what you like, but even that won't work as perfectly as you'd like it to, and I'll show you why. Joint dot position
Scale.
So as you can see, it scales everything down, but it's not really tracking all that well. So what you want to do, instead of just scaling to 640 by 480, you want to make it scale a little bit more and shrink it down so you don't actually have to reach everywhere and move around.
You divide by the depth or some function of the depth.
Yeah,
Shouldn't
closer.
need to.
The closer you get to it, the more accurate the position will be. As further away, the disparity between the externals.
The scale used to work much better than that.
I think they used a bit higher.
There is a way to smooth it, and I can go through that, but we're running out of time, so I might just get it to quickly
So what's with the
fire off events. I mean, it does sort of track you. If I get time, I'll go back to fixing that up. I just want to quickly run through how to get it to control something and how you would actually use this to make something. Because it's all good and well to be able to track and use the skeletons and stuff, but you can't actually use it. There's not much point. So just quickly run through that. What you want to do is every time you're changing that, you also want to process it. So we'll make another method called process gestures, I guess. And we'll want to pass it each of these things. So we want to pass it each of the joints. Now, if I was coding better, I would have made this a little bit more modular so I wouldn't have to copy and paste. But, as you do. And right. Now let's create this method. And so essentially all we're doing is doing a whole bunch of if statements based off the x and y positions, well just the x positions actually, of the joints. So if the head's x value is greater than the right hand, so let's do less than. So what we're going to, essentially how we're going to do it is, based on if you're standing out here, and instead of doing a full gesture, because we don't really have too much time, what we can do is, if I lift my hand further away from my body, so once it passes a certain level away from my body, then I'm trying to probably do something like that. And so we can fire off the event, or we can, tell it what to do. And if I'm using my left hand and my left hand's relative to my head far away from my body, then we can do something. So that's what we're trying to set up. We'll just set what distance that is, how far away our body needs to be. So I think this would be 0.5 meter. Distance. You want to do something, and move right, and copy and paste that for the left position to greater than left position X. So. And now we're just using the simple visual code that we normally do in Visual Basic or C# to control anything, and that's system.windows.forms. Send wait. Let's send key right. Okay. Missing bracket somewhere. So I suppose if we just test this out, it's not perfect, but what should happen is should go here and tab into the right document. When it tracks me wherever I am, I can now control the cursor like that. Now, because it's a PowerPoint thing, you don't actually want it to fire off this event so many times, but you can fix that using a Boolean statement saying if it's fired once, then don't fire until I've gone back. So, in about half an hour, you made a very simple Kinect application that does it. You got your camera, you got your skeleton, and you got it to control something. I think we're going to get kicked out soon. I think there's a lecture in afterwards, so we might wrap it up. Thanks for coming. We've got prizes, and I think James has an announcement to make. Do you want it on the report? I don't know.
Yeah, I was just going to say, if anyone's interested in doing some development work,